In this video, we are going to look at root and decay, which is another application of first order differential equation. In many natural phenomena, quantities grow or decay at a rate proportional to their size. For example, if you have y is equal to y t, is the number of individual in a population of animals or bacteria at a time which is t, then it seems reasonable to expect that the rate of growth, which is y prime of t, is proportional to the population, which is yt. That is y prime t is equal to k yt, and the k here become some constant. Now the mathematical model given by the equation this can be predicted what actually happens fairly accurately under an ideal condition. That's unlimited environment, adequate nutrition, immune to disease. Also, we can see many examples in nuclear physics, chemistry, and finance. So in general, if yt is the value of quantity y at time t, and if the rate of change of y with respect to t is proportional to its size, which is yt, at any time, then we can have that our dy over dt is equal to ay. Note, this is one important equation that normally is used. So now let's try and explain the variables where k is a constant, right? Now this k, if the k is greater than 0, we have a name given to it, which is the law of natural growth. When you solve k and k is greater than 0, it falls under the law of natural growth. And if it's less than 0, if k is less than 0, then we call it the law of natural decay. Let's take note of that. Then we have the law of exponential growth and decay, which we can write as y is equal to e, that is c e k t. Another important equation which is mostly used in growth and decay solving. Let's try to explain something here. The c that we see, the c becomes the initial value. So c is initial value, and the k here becomes the additional constant. Are you getting it? So k is additional constant, which is the constant of proportionality, and which can be found from using additional information. So with k we use additional information from the question given to us, but with c we use the initial condition from the question given to us. So let's do some proving here to know how the first order differential equation was applied to get these formulas, right? So now we know that we've established that to prove, let us take the initial time. So we are taking the initial time quantity is known, and the initial time quantity is known as y t naught is equal to y naught. So we are using the initial quantity. Therefore, from the equation that I developed, that dy over dt is equal to ky, we can do this by using separation of variables. That's separable differential equation to solve this. And with the separable differential equation, we try grouping where y is y and where t is t. So therefore, we are going to have our dy over y is equal to k dt. Then we try integrating both sides. So we integrate this side, and when we integrate, you are going to get ln y because this is 1 over y, which is ln y, and this is going to give us what? K kt plus c, because there is 1, and when you integrate 1 with respect to the t, you are going to get t. We are going to get kt plus what? C. Then we are trying to make y the subject here, so we are going to take ln of both sides. That's ln here, so we are going to take exponential of both sides. So we are going to get e ln y is equal to what? E exponent k what? Kt plus what? C. And then this can cancel this. We have our y, and we can expand this as what? E exponent kt times e exponent c. E exponent c is still a constant, so we can have our y should be equal to e, that's c e exponent what? Kt. That is how we derive our formula, which is very good. That formula that we had, which is the law of what? Exponential growth and decay. Now let's take something here. We're using the initial condition because with every question, we need to consider the initial condition and add additional condition to find our k and our c. It's very important. So for the initial condition, we know that our y not y0 at y0 at time 0, y will be equal to what? Y naught. Whereby this means that our t naught will be equal to 0 and our y will be equal to y naught. So now let's do some substitution here. So when you do the substitution to this equation, you're going to get what? Our y naught is equal to what? Our c1 e exponent 0, because our t is 0, it will make the k 0, so we get this. And from here, we can find our what? Our c, which is our c, the initial value, because this becomes 1. So our c1 becomes what? Our y naught. As very simple as that. So that's what we do. As very simple as that. Now let's take some example from questions which you can apply. Population, that is rate and decay with first order differential equation. So the first question we are going to consider is that a certain culture of bacteria grows at a rate proportional to its size. If the size doubles, so we have another key here, doubles in 4 days, find the time required for the culture to increase to 10 times its original size. I know you are familiar with this question because in physics, you know this. So there's one application. It's also an application under first order differential equation. So what do you do? Now we try using the initial condition to find our c, and then we use other condition to find our what? Our k. Then we can find our t. So in that case, we use the initial condition. Now we will let pt be the what? The size of the culture after t days, right? So therefore, when you do that correctly, you know that our Tp will be what? The P over the T will be equal to what? Kp. So from here, then we are going to use the initial condition, which shows that our P naught, P0 at time 0, then we have our P naught. And let's look at something here. For us to find the initial value or our constant or habitual constant, which is C, we come here that they say if the size doubles in 4 days. I guess, and so that means that when P is 4, we are going to get what? Our 2 times what? Our P naught, because it's stated here, which is the initial condition. Then from there, we can go on using our formula, which our formula shows that our formula is what? Our P is equal to ECKT. And in this case, we are trying to find our C. And therefore, we are going to use the initial condition. So we take it as what? P naught is equal to what? P naught. And therefore, T is equal to what? 0. And our P is equal to what? P naught. So therefore, we do substitution here. We have our P naught is equal to what? Our CE naught. Because our T is now 0 here. And at the end, we are going to know that this will turn to 1. So our C is equal to what? P naught. So we've gotten our constant. Then we will have that our P is equal to what? Our P naught EKT. We know that our C here has been substituted. So we know that our C now is P naught. So we substitute it here. And then we finding the K, we are going to use the additional condition given to us, which is, they said what? Find the time required for the culture to increase to what? 10 times to its original size. 10 times its original size. And if the size doubles in 4 days, that's also an additional condition and information that we're going to use. So therefore, we are going to have that from what we established, that our 2p naught is equal to 4. In 4 days, the size would what? Multiply itself by 2. We are going to have that our 2p naught is equal to 2p. Our 2p naught is equal to, sorry, this will be, let me reduce the size of the eraser. It will be p naught. That our 2p naught is equal to p naught e exponent what? 4k, because now we have that our p naught, that's at 4p time, we have 2p naught. So therefore, we have it to be 2p naught is equal to, and the time here was what? 4 days. So we have it to be t. So then we have it 4k. Then we can find our k here using the additional information. And we can have our k to be, we know that we can divide through by p naught. We are going to get 2 is equal to e exponent 4k. And then when we're going to take ln of both sides, we're going to get ln 2 is equal to ln e exponent 4k. This is going to cancel this. So therefore, we are going to get that our k is equal to what? Ln 2 over 4, which is equal to 0.173. So therefore, we've gotten our k. So we use the initial condition to find our c, and we use the additional condition to find our k. Then we are finding the time. So in the time, they say what? The time required for the quarter to increase 10 times to its original what? Size. So therefore, for the time, we know that to be 10p naught is equal to p naught e exponent what? 0.173 t. And therefore, we find it, we'll cancel it by t naught. So we are going to get the same. We are going to get 10 is equal to e exponent 0.173 t. And then we find the ln of both sides. We are going to get ln will cancel this. We are going to get our t to be equal to what? Ln 10 over 0.173, which will give you 13.31. It's very simple. One advice I'll give you is that you should try expose yourself to many questions as possible regards to the growth and decay. Let's take another question. So with this question, they say a radioactive material has an initial mass of 100 milligram. After 2 years, it's left to 75 milligram. Find the amount of material at any time. What is the period of its half-life? So in this case, we know that we need to find the what? There is an initial condition, and this is half-life with radioactive. So from there, we measure the amount of material present at a what? Any time, and we have it to be dy over dt is equal to what? Ky. And when you do this separately, we know that we have our y is equal to e kt. We did that with the proving. So then we know that for initial condition, we are going to get that initial condition. We know that always our y time naught is equal to what? Y naught, whereby our y naught was, the initial condition was given that the initial mass was what? 100. So we have our initial mass. So therefore, we can find our c. In this case, our c, we have y is equal to what? E c k t. Now we have, for the initial, we know that y naught is equal to what? E c naught, because time here becomes what? 0. And when it affects the key, it becomes 0. Therefore, we can have that our y naught now is 100. So 100 is equal to what? E c naught. Therefore, 100 is equal to what? C. So we have our c constant. Then we move on to our k. As I told you that with the k, we are going to use additional information. For additional information, you know that y, now we have y, we have our c to be 100 kt. So we are finding our what? K. So therefore, we are going to do some substitution. Now they say that after 2 years, so y2 is equal to what? 75. I getting it? Yes. So 75 equal to 100 ET. Then we'll try solving it. Now 2 years, right? So therefore t becomes 2. So we have 75 is equal to what? 100 E 2k. This is additional information for us to find the k. Then here we can find that our length 75 is equal to what? This will be length 75 over 100. Length 75, so length 75 over 100 is equal to what? 2k. Yeah, it's equal to 2k, because you find the length of both sides and the length will cancel. From here, let me do something for you. So we are going to get 75 over 100 is equal to E2k, and 75 over 100 is 0.75. So therefore, when you find the length will cancel the E. So you are going to get 2k is equal to what? Length 0.75. Then you divide through by 2. So k will be equal to then 0.75 over 2, which will give you an answer of negative 0.1438. So now we have our k. The question was asking us to do something. We have our k to be negative 0.1438. We are supposed to find the half-life, right? So from the equation, we can now generate that our yt is equal to 100 e exponent negative 0.1438 t. And in this case, they ask using the half-life. So with it's 100 milligrams. So what will be the half of it, which is 50 milligram? Therefore, we'll have that our y is equal to 50 milligram using a half-life. I get it. So when you equate it, you're going to get 50 is equal to 100 e exponent negative 0.1438 t. This is for half-life, because for it to happen, half of it will be what? 50 milligram. I get it. And then you solve it to get a t. The same way is very simple. You're going to get divide through by 50 over 100 is equal to e exponent negative 0.1438 t, and this will be 0.5. So you take the length. So length 0.5 is equal to length e exponent negative 0.1438 t. This will cancel this. So at the end, you're going to get negative 0.1438 t is equal to length 0.5. And then, since time is not a negative figure, when you get negative price, it's going to give you the same answer. So when you do that, you're going to divide through by length 0.5 over negative 0.1438. And our time will be given us as 4.82 years. As very simple as that. So please, as I said, expose yourself to a lot of questions, and you know how we can solve a lot of questions when it gets to